Then Guillain-Barré. Remember, I told you it's progressive from bottom up, from the legs upwards. We need that today because we are going to learn another disease similar to that. And then we did epilepsy classification. We learned to read a bit of EEG, just the related ones. And then treatment of epilepsy, management, how to start a drug, how to stop a drug, and which drugs you should never give a female. Then we did about the diencephalon. This is I didn't tell it there, but this is the limbic system, major part of the limbic system that was discussed. Like this was under Wernicke-Korsakoff syndrome, the Papez circuit. And oh, sorry. Then we did about coma, the reticular formation, how it can either lead to epilepsy or coma. And we did, what is it? Parkinson disease, basal ganglia, the direct pathways, indirect pathways. And last week we did about stroke. So we're going to start soon. And this image, it's one of the most important things because it makes your life so much easier when it comes to handling stroke related questions. And this image I added later. This is what happens in AV malformation. Basically, the brain is going to be destroyed in such a way, you can see. So, and then we did the subdural hematomas, what I called, this was frequent fallers club, because they have a history of falling. And then the subarachnoid hemorrhage. And I told you the circle of Willis is floating in the subarachnoid space. And right now, I'm just gonna send you guys a video that is a berry aneurysm. Let me forward this. So that is a berry aneurysm. You guys can either check it now till we start or later. Then this thing that we did, this is the biggest shortcut I can give you when you answer questions related to stroke. Wallenberg syndrome. So these cases, you can do it yourself. Now, let me start the lecture today. Guys, first thing, if you guys have any questions, you can unmute and ask immediately. Don't keep any question for later, okay? If you have a question, just unmute and ask. Second thing, please turn on your videos because I can't see people's faces. I just see so many black screens, okay? Okay. Okay, guys, we are going to start the lecture today. The first thing is the question discussion for stroke. Okay, I sent you guys these questions, so I need you guys to send me the answers now. Can someone tell me? Okay, send it in the chat. What is the answer for the first question? Just send it in the chat. What do you think is the answer for the first question? I need at least 10 to answer before I proceed. There's 50. So it doesn't matter if you're wrong, just try. There's no responses. Guys, just send me an answer. Read this, think about it, and send me an answer. I got one answer. So, okay, let me just discuss it. I don't want to waste time. Do you remember I talked about the homunculus? Do you remember I talked about the homunculus? Okay, let me just use the image we discussed previously. Remember this? And then I did another diagram over here. I talked about stroke in the anterior cerebral region and how the body is going to be affected. Okay, let me go back to this and I'll explain. So in this case, it is a tumor, but it's the same concept. Okay, so basically think of it like this. Our body is controlled like this. Okay, sensation and motor. This is just a shortcut when it comes to answering these kind of question. If they give you a question like this and they tell that there is damage to a certain area, you look at that and you can see in that homunculus image also you get the same thing. You will see the legs coming like this and then the body coming like this. Okay, I did it in a different way. I drew it in a different diagram where I said this region is supplied by the anterior cerebral artery. Okay, and this region is supplied by the MCA. Okay, I hope you guys remember this. So in this case, this patient's top region is affected. Guys, this is a lateral image from the side. If you look at the brain from the side, okay, like you cut it from the middle and look at it from the side. So in this region, you can see the legs are always above. Okay, so the answer is C. The patient will have weakness in the leg and spasticity. This word is important because this means it's an upper motor neuron damage. Can those who came for the first class, you should know what that means. So when we talk about upper motor neuron lesions, guys, if you don't understand this, just unmute and ask. Okay, this is an upper motor neuron lesion. Okay, so the brain sends corticospinal tract fibers from above, from the brain downwards, and the fibers that come from here are all upper motor neuron fibers. The fibers that exit at the level, let's say this area innervates the arm. Okay, in this question it's the leg. So let's draw a leg. Okay, sorry guys, my leg is bad. So we talked about this. The neuron that innervates the leg, the last neuron, is called the lower motor neuron. Okay, I hope you guys remember these. So you can see the damage is here. Okay, that means the upper motor neuron, not the motor neuron that originates at the level of the lesion, is damaged. So when upper motor neuron lesions are present, it means everything has increased. Hyperreflexia, hypertonia, everything is hyper. When it is lower motor neuron, it is hypo. Okay, everything has decreased. This in upper motor neuron, there's something called the Babinski sign, where you take a sharp object, okay, not one that will cause bleeding, but something sharp like the tip of your pen or a car key, and the sole of the person, if this is the toe, this is the toe, you bring it like this, okay? If there is upper motor neuron lesions, the toe will move upwards, okay? If there is an upper motor neuron lesion, the toe will move upwards. These were discussed. I'm just doing this case study so you guys understand this. Did you guys understand this? If you didn't, you can ask me now, the first question. Okay. Okay, can someone tell me? Wait, the answer for the second one. Answer for the second one. Can someone tell me the answer for the second one? We drew this last class. Remember this. This is the spinal canal, the central canal of the spinal cord. It comes up, enters the foramen magnum, and then we have the medulla region, we have the pons, and then we have the midbrain. I hope you guys remember this. So this is the spinal canal. It comes up and comes to the level of the medulla, and it forms the fourth ventricle. And then the fourth ventricle will form the cerebral aqueduct. Okay, and from there it moves forward and laterally. Okay, it moves forward and anteriorly, and this is the third ventricle. And from there it moves upwards, forward and back. We didn't discuss this yet. This is the lateral ventricles or the second ventricles. Okay, so in this question they have told that there is a mass lesion causing these two, this to be enlarged, and sorry guys, one thing, the drainage is from top to bottom. Okay, just remember it like this till we discuss this. The drainage is from top to bottom. Now in this question they say that these have enlarged, so that means, and this is normal, that means the problem is somewhere here. Okay, so this is the cerebral aqueduct. This is pure anatomy. Okay, what are the last two options? So the answer is cerebral aqueduct. Now this, okay, guys, I made a mistake here. Oh, no, it is correct. I haven't given the CT scan. I need to use the CT scan for this. I'll send it and we'll discuss this later before the class ends. The next one, a highly agitated 54-year-old man is brought to the ER because he's unable to effectively communicate. Okay, he speaks with conviction. That means he's trying to speak, but what he says are incomprehensible. Okay, this is asking which branch of which artery is most likely occluded. Send your answers, guys. What is the answer for this? At least 3 more people send, because this was a very easy part. This is all about the language center, and I discussed this thoroughly. Broca's area, Wernicke's area, and remember the Okay, I'm gonna just combine these diagrams. This is the sulcus, sorry, precentral sulcus, which divides the motor and the lateral area, motor and sensory area, somatosensory area. So Broca, Wernicke. Remember, guys, language and the upper extremities of the body is going to be supplied by the middle cerebral artery. Okay, answer is C. The legs are going to be supplied by the anterior cerebral artery. Okay, and the posterior cerebral artery, if there is damage, there's going to be vision defects. Okay, so this is the previous lecture that we did. Can someone tell me the answer for the fifth one? Can someone tell me the answer for the fifth one? This can't be hard, the fifth one.
Climb stairs?
Yes. Anterior cerebral artery innervates the legs. If the legs can't walk, it causes difficulty in climbing stairs. Okay. Can someone tell me these? Which artery? Guys, grip is from your hand. Hand is from the middle cerebral artery.
Middle cerebral.
Yes. Okay. Okay. See, I just looked at this image, and this is the image. Without reading the question, can you tell me the answer? Just look at this image and tell me the answer without looking at the question. Don't read. Just look at this image and tell me the answer.
Posterior cerebral.
Yes.
Posterior, yeah.
Yes. Okay. You can see. Okay. Now the question. Speech is okay. That means MCA is normal. Visual field defects reveals a left homonymous hemianopia. Okay. With macular sparing. We will do this. This is something we have to do in detail. It's a huge lesson in neurology. So which cerebral artery is most likely compromised? Posterior cerebral artery. And now I'm going to teach you guys. Okay, no, I will come back to this question. Wait. Yeah, because I'm going to teach you guys how to identify this structure anatomically and how to identify that in a CT, sorry, in a MRI. Okay, CT and MRI, same concepts. Okay, I'm going to tell you what this is. Okay, can someone guess and tell me what this is? If I tell you that B is the internal capsule, can someone guess? Just guess. What is A? Can someone guess and tell me what is A?
Caudate nucleus.
Yes, A is caudate nucleus. What is C? Okay, C you might not know. It's called the insula. Okay, I told you it's the most lateral part of the. See, in this region, it is the most lateral part of the temporal lobe. It's called the insula. Can someone tell me what is D? Can someone tell me what is D? Look at it, you can see,
Lobus pallidus and putamen.
yes, part of the basal ganglia. D is, this is the putamen. Sorry, I labeled it the opposite way. So guys, don't worry. We have discussed this and today we are going to review it again. Just label these for now. Globus, pallidus, and putamen. What is this structure? Both together, what is it called? What is this structure together called? Looks like a lens, so it's called,
Lentiform.
yes, it's the lentiform nucleus. Lenti, L-E-N-T-I, form nucleus. Okay. And this, I sent this question earlier. If you look at this, you can see this crescentric shape and you see the word false. What is the answer? I'm not asking you to read anything else. What is the answer?
B.
Yes, the answer is B. Okay. Let me go to that part. Remember this. I told you that the veins must travel out of the arachnoid layer, past the subarachnoid space to the dural layer. Okay. And when it goes through the subarachnoid space, I told you the brain is floating there. Okay. The brain is floating there in the subarachnoid space. So what happens if there's a sudden fall and the brain moves forward, and because this structure is held firmly by the dural region, what will happen is it will tear. It will tear here. Okay. It's going to tear and then it's going to cause bleeding. And these veins are called bridging veins. You can add that word, bridging veins. Okay. Now let's start the lecture for today. And as usual, I will start it off with a review of previously learned structures. And if you haven't learned this before, now is the time to learn these because I'm going to go from the basics. Okay. So first of all, this is the spinal cord. Okay. This is our spinal cord. I need to move it down. What is this structure, which is the first part of the brainstem? What is this structure? Guys, unmute and answer. Yes. What is the structure above that?
Pons,
Pons.
Yes. And what is above that?
midbrain,
Yes. Okay. This is, just follow these steps and you can easily learn to draw like the major part, the hardest part of the brain. Okay. Now you know that. And I told you this is the fourth ventricle, this is the spinal canal, and this is the cerebral aqueduct. Okay. From here, this will move anteriorly like this. The third ventricle forms and it moves anteriorly like this. Okay. This is the third ventricle. What is this structure over here? Give me a second. I'll just draw it like this. Wait, guys, wait. What is this structure? What is that structure?
Thalamus.
It's the thalamus. Okay, remember that. And what? There are two bodies. One is given to the ear. The other one is given. It's lateral. It is given to the eyes. Okay, it is a part of the eye conduction system. What are these nuclei called?
Genicular.
Yes, lateral and the medial. Lateral and medial geniculate bodies. So the lateral one gives innervations. This is the optic tract. The lateral one gives innervation to the eyes like this. Optic chiasma, where the optic nerve it bifurcates, it goes to the opposite sides. We have our eyeball. Okay. This is our eyeball. Now, can someone tell me what is present here? Don't fully color it. What is present here?
Hypothalamus.
Yes. And hanging from the hypothalamus, a part of the hypothalamus on the bottom, you have two structures which look like
Mammillary bodies.
yes. And what is this? This looks like a testes. What is this?
Pituitary.
Yes. They all originate from the inferior surface of the hypothalamus. This is hypothalamus. Okay. This is the pituitary gland. Okay. So these are the mammillary bodies. Guys, I'm going to tell you something, and I need you guys to, this will be important when we learn the limbic system. Okay. There are some fibers that come from the mammillary bodies to the anterior part of the thalamus. Okay. There are some fibers that come from the anterior part of the thalamus. It's called mammillothalamic fibers. Okay. When it comes to nervous system tract naming, it is very easy because they start off with the origin, the organ that originates the nerve fiber first, and then the other organ. Its name, mammillothalamic fibers. Okay, that's how they label nerve fibers that come from the nervous system, just to make it easier. Okay. So now, give me a second. Now I'm going to draw the thalami. Okay. Wait, before that, I'm going to draw the circle of Willis. Okay. What are these two arteries that gives rise to anterior cerebral arteries and the middle cerebral arteries? What is this artery here? What is this artery?
Carotid.
Internal carotid artery. Okay. This is the anterior cerebral artery, middle cerebral artery. Okay. And then from the posterior, we have, give me a second. Sorry guys, give me a second. Yeah, sorry. Okay. From the bottom, we have two arteries that come like this, which originates from a larger artery. What is this artery called?
Basilar.
Basilar artery. Okay. And what are these two arteries?
Vertebral arteries.
Yes. What from which artery does the vertebral arteries originate from?
Subclavian artery.
Yes. Okay. This is the vertebral artery which originates from the subclavian artery. Okay. This is the posterior cerebral artery. And what are these? Okay, I'm going to use a different color. What are these?
Communicating
Yes.
arteries.
Posterior communicating arteries. And what is this?
Anterior communicating.
Yes. Okay, now guys, I need you guys to understand that our pituitary gland is present like this. It is, think of it as coming down through this hole. Okay. Around the circle of Willis. This structure is called the circle of Willis. Think of the pituitary coming down like that. Okay, I'm going to draw this here. I'm going to draw it like this. Okay. Now, it comes to a part of our cranial bone, like the most bottom part of that area is a part of our cranial bone. Can someone name this? If you can, I will be really impressed. Can someone name the part it descends down to? Like, what is the cranial?
Celatrusica.
Yes, Celatrusica. Nice. Really well done. And what is lateral to the Celatrusica?
Cavernous sign.
Cavernous
Yes.
coding.
Cavernous. Okay, perfect. So you guys know this. And now I will talk about the structures. We will look at the structures. Don't draw this line. We are going to draw the structures which is going to go this way. Okay, the structures this way. Okay. So basically what we are going to draw now, the first structure, the guiding structure is always going to be the thalamus. Okay. Can someone tell me what is in the middle of the thalamus? The two thalami? Over here, what is in the middle of the two thalami? Guys, I forgot to mention two more structures. There is a gland which comes behind like this. What is this gland called?
Pineal.
Yes, the pineal body. And two more nuclei called the habenular nuclei on either side of the third ventricle, and there's a habenular commissure. Habenular nucleus, and between them there is a tract of white matter. It is called habenular commissure. Okay. Now, this is the thalami. Actually, I need to move this because I need space. Can someone tell me what is this structure which is present lateral to the thalamus? What is this structure?
Internal capsule.
Yes, nice. So, guys, internal capsule is where there's a lot of fibers going up and down. Just remember it like this. Think of all the motor fibers that come from above. They go down through these internal capsule. It is a white matter sheath, thick white matter sheath. And I told you guys, white matter is the myelin formed by the neurons. White matter is given right. I can't draw it in white, so I'm just going to draw it in light blue. The white matter, which is present in the axons, are what gives rise to the any white matter structure. Any gray matter structure is given rise to by the presence of the cell bodies. Okay, remember that. And now the next structure, which is lateral to this, it looks like a lens. Can someone tell me the name? What is the structure?
Lentiform nucleus.
Lentiform nucleus. Now, those who did Parkinson's with me, this is the, okay. This is the putamen. This is the globus pallidus. Remember, there's two. There's the medial, there's the lateral globus pallidus, and the medial globus pallidus. Okay, we did that in basal ganglia and Parkinson's disease. Now, can someone tell me? Okay, there is a structure which comes like this, goes above the thalamus, and comes back below the putamen. It comes back below the putamen, and there's a bell at the bottom, which is a very important structure. Can someone tell me what is this nucleus? What is this nucleus called?
Caudate.
Caudate nucleus.
Yes, caudate nucleus. Now, what is formed? What is these two structures, the putamen and the caudate nucleus together called? This was basal ganglia lecture.
Corpus striatum.
Yes, it's the striatum. Not the corpus striatum. This is just the striatum, because, or you can call it the neostriatum, because the corpus striatum is a combination of the globus pallidus, like both globus pallidi and caudate nucleus and the putamen. Okay, corpus striatum is a combination of all three. Just striatum is the putamen and the caudate nucleus. Okay, remember that. And what is the body which is present below, which I do here?
Amygdala.
Yes, nice. Now, since I, okay, guys, understand this. The structure I'm drawing is below the lentiform nucleus, but because I can't draw it here, I'm just going to draw the lentiform, sorry, the amygdala. Let me draw the caudate nucleus again, but this time I'm going to draw the amygdala on the side. Okay, I'm just going to draw the amygdala on the side, just for my convenience when it comes to drawing the next structures. I'm sorry, guys, I can do this, but if you are using paper, you can either draw it on the other side or just readjust. Okay, this is the amygdala. What connects to the amygdala? What structure connects to the amygdala?
Hippocampus.
Yes, it's the hippocampus. Okay, and it moves up. It moves like this. So this is the hippocampus. It moves up in the sense superiorly as the fornix. I will draw another diagram to explain this. And it terminates, it goes to the mammillary body. Okay. So I told you in the mammillary body, there's a fiber connection to the anterior thalamus. Okay. I hope you guys understand this. I'll show you guys an image from anatomy app. Now the next thing, okay, let me draw that on the side. So we have the two thalami here. I drew this under Pape's circuit. This is called the Pape's, P-A-P-E-Z circuit. And over here are the mammillary bodies. This is the hypothalamus and the pituitary. And now I told you guys below, somewhere here you have the amygdala. And we have the hippocampus, which joins there, and it travels above the thalami like this to the mammillary bodies. This is called the fornix. And I told you fibers come to the anterior thalami from the mammillary bodies, mammillothalamic fibers. And from the thalamus, it is going to send fibers to something called the cingulate gyrus. This is called the cingulate gyrus. Okay. I hope you guys understand. If you don't, you can ask me. Okay. This is called the cingulate, C-I-N-G-U-L-A-T-E gyrus. We did this under, I think it was under, I can't remember, but we did this previously.
Epilepsy and coma.
Yes, yes. We did that under that lesson. Thank you. So what is this whole structure called? It is called the, okay, this construct. It is called the limbic system. What I'm drawing right now is basically the limbic system. Okay. So this is the cingulate gyrus, and from the thalami, there will be signals going to it like this. All around it, there will be nerve fibers, basically. Okay. Cingulate gyrus. This is the structure of the limbic system. This is our limbic system. Okay. And our hippocampus is involved in short-term memory. So everything that you're studying right now has gone to the short-term memory. And it has to go to the thalami through the cingulate gyrus. It must go to the cerebral hemispheres for storage. That mainly occurs during sleep. Okay. Here are some points. Guys, should I discuss the reticular formation, or I did that several times actually. This is going to be the third time. Anyone who, okay, let me just skip it for now because we have spent too long for this. So these are the basic anatomy structures. Oh yeah, spinal cord, very important. I need to talk about the spinal cord. This is the spinal cord. How many posterior vertebral arteries do we have? Someone answer. How many posterior vertebral arteries do we have?
Two.
Yes, we have two posterior vertebral arteries. Okay. And we have one anterior, spinal arteries. These are spinal arteries. Two posterior spinal arteries and one anterior spinal artery. Okay. And this is the gray matter region. And I told you guys, during developmental stages, during development, this region develops from something called the alar plate. Okay, alar plate. So that region is going to be full of nuclei related to sensory systems. Okay, all sensory nuclei are related to the posterior part of the spinal cord, and this part is derived from something called the basal plate. And you know those fibers that come down in the corticospinal tract? So these are okay. Gray matter regions are all cell bodies of nuclei. So the lower motor neuron at that level will start here. Okay, this is the lower motor neuron that starts at that level. The upper motor neuron comes, okay, it doesn't come there. It comes from there's two nuclei. For today's lecture, what I need to highlight is these two. We are not going to talk about the motor system. We need to talk about the sensory system. Can someone tell me what is this? This region. It's a part of the dorsal column. What is this area called?
Cuneate.
Yes, it is the cuneate nucleus. Does it innervate the upper limbs or the lower limbs?
Upper.
Yes.
Uh,
And the way to remember that. Give me a second, I need to connect. So I have told you guys how to remember that. This is the gracilis, gracili, Gracilus column. Okay. Remember, our spinal cord is a tapering structure. It's thicker at the top, thinner at the bottom. So our legs are at the bottom area. This is where our legs are. So when it is tapering, that means as we go down, only this region will be found. The most bottom area, you will see only a very thin area. It's a very thin area. As we go up further and further, these areas are added. Okay. I did it in more detail. So I hope you guys understand this. Can someone tell me the function of the cuneate and the gracilis nuclei?
Two-point distinction.
Yes.
Fine touch.
Yes. So the word I'm looking for here is proprioception. Okay.
Reception.
Yes. And today's lecture is all about this proprioception and how our cerebellum functions with that. Okay. Now, in addition to that, we have our spinocerebellar pathways. There is two tracks. I went into detail during the previous lecture on spinal cord, actually the first lecture, but it receives signals. Okay. So you guys know the Golgi tendon, muscle spindles, and other pressure receptors, which you find in structures of muscles. You don't need to memorize this. Basically, muscles, ligaments, everything around muscles, tendons, nothing to memorize, just understand this. So these supply the information about position, proprioception, everything. And these, okay, one type of fiber crosses to the other side into the anterior cerebellar tract. The other type will go on the same side to to the posterior cerebellar tract, and move up. Okay. These are, I will discuss these in a different way today, but we did these for spinal cord. Now, today's lecture, we are going to start it off like this. Okay. First thing, I told you guys, when it comes to case studies, I didn't talk about anything ipsilateral. Okay. Except the last day, one thing I talked about ipsilateral, that was also related to the cerebellum. Today, I'm going to tell you something very important for case studies. If the fibers originate, if it is motor or sensory from the cerebrum, it is contralateral. There's going to be crossing of the fibers somewhere. Okay. But when you talk about the cerebellum, it is ipsilateral control. This is the golden rule for today, which you will need for case discussion. Okay. I hope you guys understand that. Okay. And there's one more thing which I will add, but it is not a major lobe. It is just the sympathetic nervous system. Sympathetic nervous system. This is also ipsilateral. I hope you guys know the sympathetic nervous system starts at T2, at the level of T2, and it moves up and it goes and innervates the eye. And if, okay, it goes around the entire body. But our concern right now is a condition called Horner's syndrome. It can lead to ptosis, meiosis, and hydrosis. Okay, this is called Horner's syndrome. If you remember this thing, it's called Horner's syndrome. It is ipsilateral. Okay, same side of the damage will show the symptoms. That is because this is our spinal cord. This is our spinal cord, and the sympathetic chain runs adjacent to it, and it does not cross. Can someone tell me with which artery it travels to the eye, to the region of the eye? With which artery? I told you it goes through the cavernous sinus. Okay, I used red here. Let me just change the color for you to understand this. I told you guys, there's the internal cerebral artery, internal carotid artery, sorry. And this runs hugging it. Okay, they run together. I told you guys this. Okay, it actually exits from the front here. I discussed these structures in the last lecture. So this is the introduction. 3 things you need to know. Cerebrum, always contralateral control. Cerebellum, ipsilateral. And sympathetic nervous system, the sympathetic chain is ipsilateral control. Now, there are some words I want to talk about before we start the lecture. Okay, so actually I will talk about those within the lecture. Let's start the anatomy of the cerebellum. Okay, I will talk about these words during each part, and you guys can come back to this and you guys can refer these later. So now I'm going to draw the sagittal section. This is the midbrain. This is the pons. This is the medulla. And here is the cerebellum. Okay, wait guys, don't draw the cerebellum yet. There's a fissure. There's 2 fissures actually. So over here, there's 1 fissure. And over here, there's another fissure. Okay, this is called the primary fissure. and this is called the dorsolateral fissure. Okay. Now, we have 3 lobes in the cerebellum. Okay, the first one is called the anterior lobe. There's one below that called the posterior lobe, and the most primitive, the one that developed first, which you can find in very lower organisms such as fish, it's called the flocculus. Flocculus. Okay, these are the 3 structures of the cerebellum. I need you guys to understand this fact. Can someone tell me the 3 connections? One comes from the midbrain, the other one is from the pons, and the other one is from the medulla. What are these foot-like processes called?
Peduncle?
Cerebellar
Yes.
peduncle.
Cerebellar peduncle.
Cerebellar peduncles. Peduncle means foot. Over here, the top of the midbrain, we have the cerebral peduncle. Okay. So over here we have the cerebral peduncle. This is called this. So there's the superior cerebellar peduncle, superior, middle, and inferior. Okay. Okay. Now let me talk about something which should help us later on. The anterior lobe can also, wait, give me a second. Okay, you guys understand this? If you have any questions, you can ask. Now, when it comes to balance, our body needs signals from 3 main locations. There has to be input from this input to cerebellum. It must come from the cerebrum. Okay, proprioception must come from the spinal cord. Third one, the vestibular apparatus, and with it I always like to add plus eyes. Okay, I just add eyes also there. So I know this, you can't memorize this based on anatomical locations, but remember this, flocculus was the first developed structure, and it received signals about the location, balance of head and eyes from the vestibular apparatus. Okay, this is related to the vestibular apparatus, and add this also, plus eyes, just add that. The next one to develop was the anterior lobe, and that got signals from the spinal cord. Okay, it is called the spinocerebellum. And the most advanced one which developed was the posterior lobe, and that got signals from the cerebrum. So we call it cerebellum. I hope you guys understand this. There's 3 main inputs, okay, and those come from here. Now let me just give you guys an introduction as to what the inputs, why the inputs matter. Okay. Cerebrum is involved in the coordination. It tells you how, it tells, okay, cerebellum, we need to move like this. This is the movement plan. I will explain this. This is the movement plan. I need you to tell me the location of all the related muscles. First thing, cerebellum, it takes information from the spinal cord. This is called proprioception. Okay, let me start from the beginning. Let me talk about the spinal cord first. Okay, our spinal cord is involved in proprioception. What does that mean? At any given time, our cerebellum knows where every muscle is. It knows exactly where each muscle is. Okay, and that signal is taken from the proprioceptive organs of the spinal, from the muscle fibers. Sorry, the Golgi bodies. What I told here, they send the muscles exact location. Okay, through the spinal cord to the cerebellum. Now the cerebellum knows exactly where the muscles are. Okay, the cerebrum is the coordinator. It tells, okay, cerebellum, I need you to tell me where these muscles are right now, because we need to start moving them. Okay, it is the coordinator. And the vestibular apparatus, it is for balance. Okay, it maintains balance. I hope you guys understand that. Let me talk about the transverse section of the cerebellum. So we are going to cut the cerebellum in the middle. Guys, if you don't understand this, just ask me. If you didn't understand any part here, just ask me. We are going deeper and deeper. That's all I can say. Okay, now we are going to cut the cerebellum from the middle. It's a transverse section. So you will see it like this. Oh, sorry. Don't draw. You will see it like this. We have cut it as a transverse section. This is also very similar to the structure of the cerebrum, because the gray matter regions are found outer. This is called the cortex of the cerebellum. This is the gray matter region. Okay, and in the middle we have some deep nuclei. We have some deep nuclei. These are the deep nuclei. Okay, so we have the gray matter. Okay, so this will be the left cerebellum. This is the right cerebellum. Okay, and we have the deep nuclei. Guys, this is what we're going to draw now. We are going to learn the nuclei. You can see this is the cerebellar cortex. We are going to learn these nuclei. Okay, and this is the cortex, and in between you can see the white matter regions. Okay, so what that means is, it's simple. Let me just tell you the way nerve fibers come to the cerebellum. They come first to the cortex, and they have a second signal to the nuclei, deep nuclei, and from the nuclei it goes out. This is the normal pathway. Okay, so in this region is where you have the white matter. Okay, the axons will be here, while the gray matter, the cell bodies of the nuclei, will be here and here. I hope you guys understand that. That's how the fibers travel to the cerebellum. Now, we are going to talk about the nuclei, and there is a mnemonic from USMLE. It's called "Don't eat greasy food." DEGF. There is one nucleus that looks like a sharp, like teeth. Okay, don't draw it that big. Don't draw it that big. We have 4 nuclei. We have to draw a total of 8 because it's present on either side. Can someone tell me the name of this nuclei? Looks, it has sharp teeth-like structure.
Dentate.
Yes, dentate. I'm gonna label it from above. Dentate nucleus. Okay, there's 2. And then we have one which is a wedge shape. And the way I remember this is because it's called the emboliform nucleus. Remember wedge shape infarctions which occur due to emboli? Cardiology, that is. Okay. And then we have another one called globose nucleus. And in the middle, we have the most, primordial. So we have to draw the same structures again on the other side. We have the most primordial nuclei, that is called the fastigial nucleus. Okay. You can see here, on both sides you have the nuclei. Here's the dentate nucleus and wedge-shaped emboliform nucleus. And next to it, you have the globose nuclei. And the most primitive is the fastigial nucleus. Do you guys understand this? Now, let me talk about their functions. Okay. I'm going to tell you the function. I need you to tell me to what region it goes to. Okay. This is involved in coordination. Does it go to which structure? 1, 2, or 3? This is involved in
1.
coordination.
Vestibular.
It goes to 1. It goes to the brain. Our brain coordinates the movement. Okay. It goes to the cerebrum. It is a part of the cerebellar pathway. It goes to the brain. These two together are involved in tone. Okay. Can someone tell me which nucleus it goes to? Does it go to the spinal cord, or does it go to the brain? The cerebrum, or does it go to the vestibular apparatus? This is tone.
Spinal cord.
Yes. And the fastigial nucleus, the most primitive, it goes to the vestibular apparatus. Okay. You guys understand this? This is the nuclei of the cerebellum. Now, guys, I will combine everything, all this knowledge together as we go to the next section. Just for now, try to understand these segments. Okay. Now we are going to look at the posterior section of the cerebellum. And this is where the cases come. If you don't understand this, you cannot do any cases. Okay. Now, here is the primary fissure. Here's the primary fissure. Okay. Actually, I'm going to use another color for that. And this is the posterior cerebellum. There's a deep groove. There's a very deep groove, which I will draw as a line like this. It's a very deep groove, basically. So this is the anterior lobe. This is the posterior lobe. And we cannot see the flocculus. So I'm going to bring it forward. Okay, I'm just going to bring the flocculus forward. Actually, you can see it here, like this. But basically, the flocculus is behind. And I need to bring it forward for you to see it properly. I hope you guys understand this. So now, our cerebellum is divided into two by something called the vermis. This is called the vermis. And that divides the cerebellum into two hemispheres. Left and right, cerebellar hemispheres. Okay. It divides the cerebellum into two, left and right cerebellar hemispheres. Now, this region, which is just adjacent to the vermis, we can call it the paravermal area. This region, which is just adjacent to the cerebellum, is called the paravermal area. Okay. I hope you guys remember the homunculus we studied in the previous chapter, because we are going to learn how our body is controlled by the cerebellum. Okay. All you have to know is this is okay. Sorry. This is our head. Have you watched the movie E.T.? This is our trunk. Okay. This is our head. This is our trunk. And our legs, our limbs go to the lateral side. So when we talk about damage, if we say cerebellar medial damage, medial part of the cerebellar damage, we are talking about the vermis. Okay. If we are talking about axial damage, it is talking about the paravermal area. Why is this important? Because, okay, let me just show you guys something. This region is basically everything from your neck to your hip. Okay, it is the region from your neck to the hip. If there is damage to this, you will get symptoms of those areas. Okay, I hope you guys understand that. If there's damage to the neck, the vermis, it leads to something called ataxia of the area from neck to the to the hips. If there's damage laterally, it leads to paravermal area damage. Sorry, it leads to damage in the limbs. Okay, forelimbs. So when you're walking, you will have an unsteady gait, weird shuffling gait and everything. Do you guys understand this? If you understood this, and if you plan to do USMLE, that is all you need to know with. Sorry. If you plan to do USMLE, that is all you need to know to attempt cases. So wait, let me find the cerebellum part. Sorry guys. Okay, here. So if you plan to do USMLE, you have, I told you guys the first rule, cerebral cortex sends fibers contralaterally. It enters through the middle cerebral peduncle. Okay, we will discuss that next. Then the output and the nuclei. Okay. So in cases, this is what you get. Lateral lesions affects voluntary movements of the extremities. Okay. What does this mean? So the medial lesions will cause truncal ataxia. That is in the region from neck to the hips. Okay. And nystagmus, head tilting. Remember, neck, head tilting. Nystagmus, dancing eyes. Okay. So let me go back to our discussion. Do you guys understand this? Because this is what is most important for questions. Now I'm going to talk about each function. First one is the coordination. Coordination in relation to cerebrum. Okay. So I'm just drawing the brain. I already discussed this once, but I'm going to discuss this again. Where does a thought process start? Which area? I'm going to label some areas. 1, 2, 3, 4, brainstem. 5, 6. Where does a thought process start? Okay, thalami here. Can someone tell me where does a thought process? Let's say you are thinking of picking up your phone from the table. Where does that thought process start?
3.
4.
Yes. Huh? Remember, I did this. This is called the prefrontal lobe. This region is where your thought processes. Anything you think starts here, prefrontal lobe. Your thought process starts here. The thought that tells you, okay, I need to take my phone. Think of this as the big boss. He's the big boss who tells you need to do this. Okay. And he tells it to the secretary. The secretary is the primary motor area. This is called the primary motor area. Okay. Guys, I discussed this in basal ganglia lecture. So it sends signal to the primary motor area. What is the thought? Pick up your phone. Okay. And that sends signal to the basal ganglia. This is the secretary. The basal ganglia, I'm just going to draw a box. The basal ganglia receives that signal. This is the secretary. So the boss told, guys, pick up the phone. The motor area informs the basal ganglia about it. Okay. And the basal ganglia has the program. It loads the program. It tells, okay, guys, to do this, we need these muscles. To pick up the phone, you need the muscles of your arm. Okay, and that goes to a secondary cortex here. That thought process goes here. Okay, this is the I forgot the name. Let me just check it. If anyone remembers the name. It's in a different note, guys. I'm sorry, I will check the name and send it. I forgot the name suddenly. Okay, so the basal ganglia loads a program and tells it to this, let's say his secretary, the basal ganglia secretary. Okay, and that secretary informs, what is this area called? What is this area called? Guys, what? Yes. Yes. The precentral gyrus or the primary motor area. Okay. And that is the one that does the action by sending fibers downwards. Okay. The precentral gyrus is where the corticospinal tract originates. Corticospinal tract, you know, that's the motor tract of our body. Okay. Again, I'm going to repeat this. Now, our prefrontal lobe, the boss, says, pick up the phone. He tells it to his secretary, the primary motor area. The primary motor area tells the planner, basal ganglia, to load the motor program for that. Basal ganglia tells his secretary, okay, this is the motor program. You need to talk with the other departments and you need to start the movement process. You need to tell the workers to start working. And the second secretary will tell the primary motor area, sorry, yeah, it will tell the primary motor area to do the work. Okay. Now, I'm going to draw a section of the spinal cord. Guys, I'm going to keep asking this question. What if there is damage to this nerve? What if there is damage to this nerve? Will there be hyperreflexia or hyporeflexia? Hyperreflexia. What if there is damage to the nerve at that level? Hyporeflexia. This is a lower motor neuron injury. At the level we need. If it is at the level of the arms will, let's say there's a damage to both systems. Okay. The upper motor neuron keeps going all the way to the legs. It goes to the legs. This is spinal cord discussion. I just want you guys to understand how important upper motor neuron injury and lower motor neuron injury is. Now, there is damage to the upper motor neuron and there is damage to the lower motor neuron So will the arm show hyperreflexia or hyporeflexia?
Hypo.
Yes, it shows hypo everything, hypo movement, hypo flaccid paralysis, everything that which relates to the word hypo. Will the legs show hyperreflexia or hyporeflexia? The legs. I told you guys, okay, this is fine. There's no damage to the lower motor neuron at this level. Guys, you guys need to review the lecture on spinal cord. The legs will show hyperreflexia. Okay. Now back to the spinal cord lecture. So then, okay, now I told you what happens, and the workers will cause the muscles to contract. Okay. Now, I told you the brain cerebrum is involved in coordination. Okay. How does the brain know where the muscles are? Where is your hand right now? How does the brain cerebrum know that? It needs input from the cerebellum. It needs proprioception from cerebellum. Okay. The information about where your arms are initially, it is needed by the brain, which is present. The information is present in the cerebellum. Okay. So the first secretary not only contacts the basal ganglia, telling it to load the motor program, it asks, where are the muscles currently? Did you understand? If you didn't, you can ask me. Unmute and ask. Okay. And this cerebellum will inform the second secretary directly. He will tell this is where the muscles are. Using that information, the second secretary causes the movement. Okay. Do you guys understand that? Now, you can't do it alone. Okay. So what is the function of the cerebellum? Coordination. It coordinates the movement with the cerebrum. How it does it is, it converts, okay, tells the initial position of muscles, of organs, using proprioception from muscle tendons, ligaments, joints, and other proprioceptive organs. Using this information, it always knows. The next thing is, always knows current location of muscles, and this is very important, plus predicts what will happen next. Now let me explain this. It always knows the current location of the muscles and it predicts what will happen next. What does this mean? You take your hand and you, okay, I'm going to stop screen share. Guys, can you see my hand now? You try this. Just take your hand and you try to put a lot of force and let go. It can come and hit your face. What you should know is it can come and hit your face, but the cerebellum predicts that is what's going to happen. So it tells the cerebrum time to stop. You can see no matter what you do, this arm will not come and hit the face while the other one moves forward. Do you understand that? It predicts. Okay. And it tells the initial position of the organs. Wait. Give me a second. Okay. Now let's say there. Let me start the session again. Guys, if you don't understand, please ask. Okay. And it knows final position of muscle. When I say muscle, it involves all the muscles, the tendons, everything. Okay. Now, what does that mean? So you take your finger and you bring it close. You keep one finger like this and bring the other one and try to touch the tips together. Just try that. Just try to touch your finger. Did you not notice that it did not perfectly come? It had to be corrected. It came and it had to be corrected. Did you not notice that? Guys, try that. Do you guys understand what I'm saying? You bring your fingers together and did you not notice it is very hard to perfectly bring it together in the first time. The cerebellum must correct that movement. So the idea is given by the cerebral cortex, bring the two fingers together and you bring it. Cerebellum has told the final position. Okay. Wait, let me go back to the board. Guys, if you don't understand this concept up to now, please ask me. Okay. So basically, cerebellum helps convert an idea to movement. Okay. That is what you call coordination. Make sure. Wait. Now, the next one is the tone. So, our Golgi bodies plus muscle spindles plus pressure receptors all these which are present in ligaments, tendons, muscles, they will fire. Okay, I'm talking about tone now. Now the tone, it's very important. It fires and it travels to two locations. Okay, it goes to the cerebrum and another one to the cerebellum, where it double checks the movement. Cerebellum double checks the movement. Okay, and predict the outcome of the next part of the movement. Okay, so okay, now this is understand this, our Golgi bodies, muscle spindles and the pressure receptors, it tells this is where I am right now. Okay, it sends those signals to the cerebrum and the cerebellum, and the cerebellum tells, okay, in the next second you should be here. Okay, you should be here, but if there is some fault in that And if it goes somewhere else, wrong final position. So in this case, if the finger goes here, it tells wrong. You need to correct it. You need to correct it. If it goes to the correct position, then it's fine. Let me demonstrate this. Guys, close your eyes and try to rapidly touch the two fingers together. Can you get it? Is it the same each time? Try that. So our cerebellum, it now knows when it's at this point, it knows it's in the wrong position. So it tells the brain back up and bring it to the correct place. So when you try to do this, the cerebellum knows it's at the wrong position. So it tells the brain back up and bring it to the correct position. Do you guys understand this? This is what you call tone. Okay. And in a defect, if there is a defect in the cerebellum, it can lead to something called overshooting. Okay. Guys, if you I will finish the vestibular cerebellar part and give you guys a break. Overshoot, I will come back to that in the next section. The third function is, okay, the tone, what controls this? The spinal cord. Okay. Next, I'm going to talk about the vestibular cerebellar pathways. Now, this is our pons. This is the medulla. This is the pons. Okay. And here's the cerebellum. There is a nerve called cranial nerve 8. Can someone tell me the name of that nerve? I told you guys how to remember it.
Vestibular cochlea.
Yes, vestibular cochlea. Okay. And its nucleus is a big one that is present from the pons above that and below that. Like this. Okay. And the vestibular section gets its signals from what is this structure? I'm drawing 3 here, perpendicular to each other, basically. Huh? What is this? The vestibular apparatus, semicircular canals of the ear. Okay, semicircular canals of the ear. If you have learned this, you should know this is related to our balance. Okay, and I'm going to tell you why I say this is balance. What's the other? Yeah, I'm going to tell you why I say that. I asked you guys to write it as vestibular system plus eyes, right? I'm going to tell you why right now. So we have fibers that come from the semicircular canals these are balance fibers. Balance signal, okay. Basically balance. So it comes, some go to the nucleus in the, this is called the vestibular nucleus. It goes there. Others will go directly to which area? Which part of the cerebellum?
Flocus.
Yes, it goes to the flocculus. Okay. And it goes to a nucleus. What is the name of that nucleus? The most primordial.
Fastigial.
Yes. It goes to the fastigious nucleus. Okay. Fastigial. Okay. It goes to the fastigial nucleus. And from there, actually, from there are fibers that go. There are several fibers, but the fiber which I want to talk about is the ones that go to the eyes. Cranial nerve 3, 4, 6, LR6, SO4, R3. You guys remember this? Lateral rectus is innervated by the 6th cranial nerve, superior oblique by the trochlear nerve, 4th nerve, the rest by cranial nerve 3. It goes to the eyes. Okay. Now, this is why I said these two, just write it together, because when there's damage to the eyes, when there's damage to the cerebellum, we get a condition which is called nystagmus. Can someone define what nystagmus is? There's a very simple way you can call it. It's called dancing eyes. Okay. Nystagmus is, it means the eye is dancing like this. I'm going to send you guys a image on the groups. Just check it. Okay. Just check this image so you guys have an idea of what is nystagmus. Guys, check the group. I sent you guys. Can someone tell me, is this horizontal nystagmus or vertical nystagmus that I sent you guys?
Horizontal.
Yes, that is horizontal. Okay. Vertical will be if the eye movement is going up and down like this. Okay. That is vertical. Now, there's a very special tract which also gets fibers from this system. I'm just gonna draw that system like this. Okay. It is a red color nucleus because of iron deposit. It has a lot of red color. Can someone tell me the name of this nucleus?
Nucleus rubrum.
Sorry. Actually, you are correct, but then that is the pathway. Tell me the common name for this. What is the common name for this nucleus? It is red in color because of iron. And yeah, it's found in the midbrain. Guys, haven't you heard of? Sorry?
Red nucleus?
Yes, it's called the red nucleus. If you guys did local A level, you should remember, you should know this at least. Okay. Our red nucleus sends fibers downwards. Let me use a different color. This system also sends fibers downwards to the muscles. Okay. So can someone tell me the pathway? Someone actually answered that. What is the pathway that comes from the red nucleus? What is the name of that pathway?
Rubrospinal.
Yes, this is called the rubrospinal tract. You don't need this much detail if you guys, okay, from my university, you don't need this much detail. You just need to know what ataxia and vertigo is. But every university is different. So I'm just going to teach from the basics all the way to the end. Okay. So the rubrospinal tract, okay, let's say the arm is contracting stronger than normal. Let's say our arm is contracting stronger than normal. Okay. Like the force that you need to give to take your pen is not what is given. It's given a huge force like that. So this is due to a cerebellar defect, because the proprioception is not working properly. It doesn't know how much force to give. I'm going to give a break right after this. Okay. So it informs the red nucleus to decrease the movement. Okay. Okay, guys, sorry. The normal cerebellum will tell the red nucleus to decrease the movement. Okay. Defective cerebellum will not be able to do that. So these people will have symptoms. And good news for you guys, when it comes to cerebellum and disorders, there's only 2 symptoms. Okay. So I will give you guys a 5 minutes break, and I will, if you guys didn't understand something, you can ask me. Okay. Guys, have a 5 minutes break. We'll start at 8:17. Sorry, 6:17. Guys, we'll start the lecture again. So please turn your cameras back on. So let me quickly do a recap of what we learned. Okay, what is this organ? Unrelated, but what is this organ?
Pituitary.
Yes, it's pituitary. Okay. This is the anterior lobe. Okay. You can see it is more anterior to the posterior lobe. And what is this lobe? Come on, guys, answer.
Floccular.
Yes. Now, what is the function of the flocculus? What is the function of the flocculus? It is related to which systems?
Vestibular apparatus and the eyes.
Yeah, eyes, it has to be in this, okay? It is related to the vestibular apparatus, but because there are nerves that go to the eyes, I add it there. Now, you can fade it, okay, hide it. What is the function of the anterior lobe? What is the function of the anterior lobe? It is connected to which system?
It's for proprioception.
Right.
Yes, it's related to our spinal cord, so proprioception. Okay, and what is the function of the posterior lobe, the biggest lobe? One word.
Coordination.
Yes. Okay, it's involved in coordination. Anterior lobe for proprioception, and the flocculus for vestibular balance, basically. Sorry. Okay, it's involved in balance. Guys, now I'm going to talk about vertigo and ataxia. And before I start, I will tell you what vertigo is. Okay. Okay. Over here in the definitions, let me come back to this. Vertigo is basically called the illusion of movement of the body or the environment. Okay. That means you feel like your body is moving. It feels like, okay, it feels like being dizzy, but the causes of this is entirely different. Okay, it's the same feeling as dizziness, but the causes of this is different. Okay, because you get nausea, vomiting, or gait ataxia. Dizziness is something that is because of our brain getting our brain is not getting enough oxygen, glucose, or blood. What is this going to cause? A 3-word thing: transient ischemic attack. Okay, so it can lead to a short bout of dizziness and dizziness can lead to fainting, syncope. Okay, I hope you guys understand this. Now, ataxia, it is basically clumsiness of movement that is not caused by muscle weakness. Okay, think of a drunk. Think of a drunk, an alcoholic. That is the way these people walk. Okay. Nystagmus is dancing eyes. Tinnitus. Have you guys ever felt? Do you understand what ringing sound of the ears? It's like you hear. Okay, that is what you hear in in tinnitus. It's like you keep a tuning fork next to your ear. That is that same sound. Okay. And this word, dysdiadochokinesia, dysdiadochokinesia, it is defect in rhythm and amplitude of movement. So basically, you ask a person to flip their hand, okay, like this. These people who have problems in who have dysdiadokinesia, they will not be able to do it at a proper rhythm, and they will not be able to they will not be able to do it at a proper rhythm. They will do it slow, they will do it fast. It will be weird. A better way to check this is have the patient tap the foot quickly. He will find it difficult to maintain a proper rhythm. Okay. Even here, if you ask him to repeat a syllable, he won't be able to have a rhythm. He will stop somewhere, start again. Proprioception, the way you should know it is position of all muscles at all moments. Okay. And dysarthria is speech disturbance. Okay. And dysmetria is unable to assess distance. What does that mean? Dysmetria is you ask the patient to bring the hand and keep it like this. He will not be able to keep it properly. He will be going all over the place. Okay. Now, guys, we are going to start vertigo and ataxia. If you guys have any questions, you can ask me. Okay. When it comes to vertigo and ataxia, these are the only two symptoms you need to know when it comes to cerebellar. Okay. Whatever the disorder is, they will say the patient has ataxia or vertigo. And I'm going to divide this into two. Oh, this is actually the hard part, which most students don't get. When I studied in our university, even I didn't get it. I had to do so much self-study to understand this. I'm going to call this side central vertigo or cerebellar ataxia. Okay. The two symptoms, two names. Okay. The other side, I'm going to call it peripheral vertigo and sensory ataxia. Okay. Now, let me tell you why I did this. The reason is this is our cerebellum and the brainstem. Okay. Then on the other side, we have the inputs and the outputs. Okay. Guys, I need a bit of space to write something under vestibular system, so leave some space. The other input is from muscles and limbs. Now we are in the clinical area part of our lesson. Okay. This is the clinical part. And we have our output, which is the, I want to highlight this: eyes, mouth, and other. Okay. Do you guys understand this? Now, remember this: central vertigo or cerebellar ataxia is damage to anything of the central nervous system. Okay. If there is damage to the cerebellum, it can lead to central vertigo and cerebellar ataxia. If there is damage to the vestibular nucleus of the brainstem, it can lead to the same. You guys understand that? And like I said before, this is the region of damage. This is the most important part for you guys to understand. Okay. Can someone tell me if there is, okay, this is the vermis. Okay. What is this area?
Paravermal.
Yeah.
Parallels.
Guys, if you have to memorize that, you will have to study anatomy from the beginning. Okay. This is basic labeling. Can someone tell me what will happen if there is going to be damage to the vermis area? Which muscles will be affected?
Trunk muscle.
Yes, the muscles of the trunk, neck downwards. Okay. So if there is damage to the muscles of the trunk, it is called trunk ataxia. Okay. Trunk ataxia. What this means is the person will have head bobbing. Okay. They will have head bobbing. They will also have something called a wide based gait. They basically appear drunk. So I will recap after this. Basically, this is how they will walk. They will walk to all the sides. Okay. If there is damages to the appendicular area, that means the limbs, is called appendicular ataxia. And the way you check that is, this is our hands. So you do something called the finger nose test, or you do some rapid alternating movements. So finger to nose. Okay. If there is ataxia, think of ataxia as abnormal movement or inability to reach the final destination. Think of it like this: the finger cannot reach the final destination. Okay. Remember ataxia as, this is just for you to remember, difficulty reaching final destination. It's just for you to remember. Okay. This is the way I remember, and that is more than enough, unless you're from a university which asks definitions. So when it comes to case studies, when you get, okay, guys, I hope you guys know, in any exam, neurology is the biggest part. In any ERPM, whatever exam, neurology will be the biggest part. You will get the most number of questions. Next is going to be the cardiology section. Okay. In any exam, always remember, if your neuro is bad, you can forget passing an exam. Okay. Even for the USMLE exam, someone has sent me a message. Okay. Even for the USMLE exam, starting next session, they're adding even more neurology questions. Okay. If your neurology is bad, it is very difficult to pass any licensing exam. Prefrontal. I got a message. I will show it later. Do you guys understand this? If you didn't, you can ask me. Now, what if there is, this is what you call central vertigo or cerebellar ataxia. I didn't talk about vertigo, but in central vertigo, what happens is these symptoms will be present. Okay, change this to nystagmus. Actually, it's better if I teach peripheral vertigo before that. Now, we'll go to peripheral vertigo and sensory ataxia. Here, there is a problem in proprioception. Okay. So, guys, do you remember something called the Romberg sign? Can someone tell me the Romberg sign?
Is it when you close your eyes and now you cannot?
Exactly. So when it comes to our balance, balance needs signals from 3 locations: eyes, vestibular system, and cerebellum. Okay. Remember, for balance, if there is any damage to the cerebellum, and if your eyes are not working, let's say in the dark, okay, let's say in the dark, the patient will be stumbling, basically stumble in the dark. Patient can't figure out where to go, okay, because 2 systems are not working and 1 system alone is not enough. He can even fall. I hope you guys remember this. And I told you guys, so there are output to the eyes 3, 4, 6. Okay. The patient can have nystagmus. Do you understand this? Patient can have nystagmus. Okay. In peripheral vertigo, you get horizontal nystagmus. Never vertical. Okay. This is actually the best way to diagnose these patients. So let's say a patient comes saying, I feel dizzy all the time. One question you ask, one question you ask is, have you ever felt vomitish or have you fainted? If the patient says he has felt vomitish, you need to immediately think of vertigo. Okay. I will explain that if you didn't get it. The other thing to ask is, have you fainted? Fainting happens in dizziness, not vertigo. Okay. Patients don't know to differentiate this. So they will be like, I feel dizzy all the time. And one way to diagnose if it's vertigo or dizziness is ask the 2 questions. Have you felt vomitish? Have you fainted. Based on it, you can tell if it's vertigo or not. And from there, you need to decide if it's central or peripheral. Let me draw a diagram. Patient comes, says dizziness. You ask, this is actual dizziness. Guys, this is for your case discussions. Vomiting or vomitish feeling, nausea. Okay, you need to decide central or peripheral. Okay, and the best way to check this, okay, more serious, there is going to be horizontal nystagmus, never vertical, never vertical. Okay, these come and go. These attacks, peripheral vertigo, these attacks come and go. Okay, when it comes to central, it is more difficult to identify that, because slight everything except the nystagmus, which is all directions. And one more thing, there can be hearing loss plus tinnitus, ringing sound of the ear. Any 4th, 5th year who has studied ENT, can you tell me what is the disease in which you get all three of this? You get, okay, you get, in this disease, you get ataxia, vertigo, hearing loss, and tinnitus. Can you tell me the disease?
So,
Huh? It starts with the M. It's a French word. Come on, guys. This is ENT. It's Meniere's disease. Okay. Meniere's disease. It's a triad of these three. Now, let me talk about how these patients present. Okay. Oh yeah, for this peripheral vertigo, I will add this also. Ataxia. Okay, no, I can't add that there. Do you guys understand this? So if there's a dysfunction in the vestibular system, you have three main symptoms. Okay, disequilibrium and unsteadiness. Nausea, vomiting. This is why I said in peripheral vertigo, you can differentiate that from dizziness. If there's damage to the vestibular system, you will definitely get nausea and vomiting. Okay. And guys, where does alcohol affect? Is it the cerebellum or is it the vestibular system? Can someone tell me? Where does the alcohol go and mix with the fluid?
Cerebellum.
It actually affects the vestibular system. Okay.
Okay.
Drugs and alcohol. Alcohol, what it does is it enters into endolymph and it disrupts the function of the vestibular system. Okay. That's why you get loss of balance. Okay. Do you guys understand this? Now, let me quickly recap. Okay. I need to add one more thing. Proprioception. I talked about the Romberg sign. Heavy, unsteady gait. I need to add that too. Heavy, unsteady gait. What does that mean? The patient will keep their foot down like they're climbing a rock. It's like they will put a lot of pressure on the floor when they keep their foot down. See, remember, our proprioception means a map of exactly where the muscles are at one point. Okay? The muscles in proprioception, what it means is muscle location is known perfectly. But in these people, heavy unsteady gait means their cerebellum doesn't know, or their proprioception pathways are damaged, so they cannot tell exactly where the muscles are. Okay, so they will put a lot of force. They don't know the final starting point and they don't know the ending point. Okay, have you guys ever climbed stairs and while using a phone, and when you reach the final step, you don't realize it, you keep your foot again, you put a lot of force downwards? It's the same thing. These people will be putting a lot of force downwards. Okay, did you guys understand this? I will do a recap and I will bring everything together. Just trust me on that. Next, we have dizziness and versus vertigo. I talked about this. Dizziness occurs after a transition ischemic attack and may lead to loss of consciousness. Vertigo is the illusion of movement or the body. Patient basically says dizzy. He feels dizzy. And treatment of vertigo, you can give antihistamines. You can give any antihistamine, but Oxford, some textbook says these drugs. Okay, if you know any antihistamine, like okay, tell me a simple antihistamine that you know. You might know this drug. Okay, forget that. This is called scopolamine. It's an anticholinergic which you give for motion sickness. So if you guys don't know this, there are people who have who vomit when they travel in the vehicle. That is because there is going to be vestibular dysfunction. Okay, and that leads to cerebellum to cause activation of something called the vomiting center. Okay, and the way to treat that is scopolamine. Okay, and amphetamines, ephedrines, they are the drugs. Okay, now look at this clumsiness of movement. Okay, let me rephrase it like this. Final destination point. Let me rephrase it like this. Okay. So that means it can affect the eye movement. Our eyes are rapidly moving muscles, which must be perfectly coordinated. And if this is affected, it can lead to nystagmus, speech, because the muscles, laryngeal muscles, they don't know where to stop. What is the final destination? So they will have abnormal speech disorders. This is a motor disorder. And this I explained. If it is in the vermis, it is trunk ataxia. If it is in the limbs, it is hemisphere, or there was another word, appendicular ataxia. I just know it as hemisphere damage. You can write it as appendicular ataxia, or you can just remember it as hemisphere damage. Now the question is, what causes damage to the cerebellum? Can someone tell me a sudden cause, sudden onset ataxia? Patient was fine, suddenly unable to move. A sudden cause of ataxia. Okay, not unable to move. He walks like a drunk. I gave you guys the answer.
Alcohol.
Yes, alcohol. Another one is stroke. Strokes are usually sudden onset, and this is called Wallenberg syndrome. In Wallenberg syndrome, you can get ataxia, or it could be a hemorrhage. It could be a ischemic stroke, or it could be a hemorrhagic stroke. Okay. Alcohol enters endolymph of ear. If it is episodic, it could be Meniere's disease, benign positional vertigo, ENT. These are ENT topics, and transient ischemic attacks. Okay. Chronic progressive. Can someone tell me the most common chronic progressive disease? Chronic progressive disease.
Is it a tumor?
Sorry, it's a very
Tumor.
yes, exactly, tumor. Remember, if this is the cerebellum, a tumor will not come suddenly. Okay, unless it's a metastatic tumor, but even then, that is not a problem here. A tumor grows slowly, 1 month, 1 year, 5 years. Okay, it takes a long time, and it grows slowly. It could be toxic, some toxic injuries, or autoimmune. Okay, guys, we have very little to do. We are almost done. So let me quickly finish this and I'll recap everything. Okay. So, okay. When there is cerebellar ataxia, guys, I will do a recap of this. Just understand this. When there's cerebellar ataxia, you get a reduced muscle tone. Okay. That means the limbs are easily displaced by a small force. Like the strength is not present. Okay. This is because of proprioception defects. Okay. Then in coordination, overshooting during movement, also part of cerebellar ataxia. Okay, these are symptoms of cerebellar ataxia. Okay, I told you guys, overshooting movements, if you ask the patient to bring his fingers together, he will take a long time trying to just bring to the final point. Okay, and remember, walking is mostly affected due to rapidly changing direction and greater movement complexities. Eye movement abnormalities, nystagmus. Okay. Now, okay, what is given here is basically the same thing I discussed in this image. If it is trunk ataxia, so if you study this in a university which uses PPTs, you will get this list to memorize. You will not understand exactly what it is. Okay, that's why I said understand, go to your university and memorize these. Okay, so vermis is trunk, paravermal area is limbs. Similarly, in the cerebral cortex, even if I draw it from the front or from the side, remember these two homunculus structures, MCA, anterior cerebral artery, legs. It's an upside down man basically. Okay, remember this. Actually, for this one, the image is legs here, body here. But just remember it like this, it is easier. So guys, remember in stroke we discussed 3 circulations to the cerebellum. Here is the PICA, posterior cerebral inferior cerebellar artery, and this is anterior inferior cerebellar artery. From the name you should understand. And this is the superior cerebellar artery. These are the blood supplies to the cerebellum. Okay, now I'm going to recap everything that we learned today. Okay, so guys, take a, okay, I'm just going to write it here. Cerebellum has 3 functions. Okay, the first function is coordination. The second function is coordination. What is the organ which it involves with it?
Cerebrum.
Yes, cerebrum. The next function is tone. What is the organ that involves in tone? Yes, spinal cord. And the third one is balance. 3 functions. What is the organ involved in this? Vestibular system. Okay, the reason I said plus eyes is because if there is damage to the vestibular system, the eyes will also be involved. Okay, you will see the damage by the dancing eyes. Now, the next thing, first, cerebellum has 3 functions. If there is a defect, in either the central system or the peripheral system. So what are the peripheral systems? One is the vestibular system. Second one is proprioceptive system. Third one is eyes. Central, brainstem, red nucleus. Anything in the brainstem anything which is there and the cerebellum. Okay, if there's a defect, it leads to two symptoms. Okay, it leads to two symptoms. One is vertigo. Okay, guys, we need to separate the two symptoms. I'm gonna describe and signs. Okay, what is the symptom and what is the sign? What is the symptom and what is the sign? Ataxia is a sign. Vertigo is a symptom. I know there's associated nystagmus and everything, but ataxia is something you can find. Okay, so what you do next is you ask the patient. Okay, next thing you do is you ask patient to sit down. Okay, you ask the patient to sit down. This is the first examination we do. Examination. Okay, you ask the patient to sit down. After you take his history, you ask the patient to sit down. The patient, now this is important. The patient is now sitting down. Okay, he falls to the left side. He has a tendency. Can someone tell me what side of the cerebellum is damaged?
Left.
Left. Remember, cerebellum is the cerebellum and the sympathetic nervous system are the only ipsilateral systems. So I hope you guys know in anatomical drawings, this is usually the right side, this is usually the left side. So the left side is damaged. He tends to fall towards the direction he has a problem. Okay, now you know his left cerebellum might be damaged. Okay, next what you do? You do the finger nose test. He's still sitting down. Okay, the patient will have intention tremor at beginning and end, plus overshooting. Okay, intention tremor is at the start of the movement, finger to the nose. At the start of the movement, you tell him, bring your finger to your nose. The patient will start with the tremor and he will bring it to the nose, and near the nose, he will not be able to like keep steady. Okay, cerebellar damage, cerebellar, this central or peripheral damage. Okay, next I call it the hit your face test. You can do this to confirm. Okay, that's not a real test, guys. It's not a real test, but basically you take that patient's hand, make sure that his hand is directed to his face, and you put a lot of force and release. If he was normal, if there's no damage to the cerebellar, the entire system, he will never hit his face. Okay, remember that. Next, this is basically diagnosing these patients in a way You will never find this in any books. I'm making it up right now. Okay. You ask the patient, you just check his legs. There will be strength, okay, but it will be something like 4 out of 5. Okay. Next, you can assess eyes. You can assess the eyes for nystagmus. Okay. And from this, you can come to a conclusion, not a conclusion. You can come to a, how do you say, idea if it is central or peripheral. Okay. You guys understand this? If you don't, you can ask me. And next, you ask patient to stand and walk. Okay. Now, let me just do this. Let me just do this. You are still not sure if it is a vermis damage or if it is a appendicular damage. Okay. If he has heavy, unsteady gait, oh wait, it's wide gait. This is, can someone tell me, where is the damage? Where is the damage if it is heavy wide gait? Vermis or the, yes. Okay. Can walk normally or tends to fall. Oh, wait, call it ataxia to left side. Like his left leg seems to be taking him in an entirely different direction. Okay. Guys, I need you guys to understand all this I'm doing right now is for case studies. Okay. You will get these symptoms in the case study. You will hear the words heavy wide gait. You should immediately understand it is due to vermis damage. Okay. Do you guys understand this? Now, can someone tell me what is ataxia? Just give me a basic definition. Guys. I can't hear. I'm sorry. I can't hear. There's a connection issue. Can someone tell me what is ataxia?
In reaching the final destination.
Yes. Difficulty reaching the final destination. What is vertigo?
The body feels like it's moving.
Yeah.
As an illusion.
Yeah. Okay. Here's the exact definition. Where is it? It's in the vocabulary. Illusion of movement of the body or the environment. Visual illusion of moving back and forth. It's basically dizziness. Okay, and I know for a fact almost everyone has had this impulsion, like while you're sleeping you usually get this kind of symptom. It's not a disease process, it's normal, but this is something that happens while you sleep. You suddenly kick out, you feel like something is pulling you and you feel that. Okay, do you guys understand this? Because I'm going to send case studies and I need you guys to localize the lesion. You need to know where is the damage coming from. Okay, you guys understand this? Cerebellum is honestly the most confusing topic. So just go through this once again when you're done. The main thing to go through is this part. Okay. I don't want to do, okay. Let me do Friedreich's ataxia. Just, I know it's too much information for one day, but let me just do this. This is a autosomal recessive disease. Okay, so this is a disease in which there is impaired mitochondrial function. That means ATP is not being produced. Okay, and this causes damage to various organs. Okay, so if it causes damage to the nervous system, it leads to ataxia. If it causes damage to the heart, it causes HOCM. Can someone tell me what is HOCM? Guys, those who did cardiomyopathy, who have learned cardiomyopathy, can someone tell me what this is?
Hypertrophic cardiomyopathy.
Hypertrophic obstructive
cardiomyopathy.
Okay. Is it this one? Is it, which hypertrophic cardiomyopathy is this? There's 3 types. Okay. And in this case, I'm just drawing the left side. Or is it this type? Which type is it? Is it the one in the middle, left or right? Which type is this? Guys, answer this. Which is, yes, HOCM is where the septa, interventricular septa, enlarges. Okay, this is dilated cardiomyopathy, and this is restrictive cardiomyopathy. Okay, we have done these. The other one is pancreas, beta cells. So insulin is deficient in these patients. Okay, this can lead to diabetes mellitus. Next, this is an autosomal recessive condition. So we need to talk about the genes and which gene is affected. Okay, so in chromosome 9, there is a gene called the FXN gene. Usually, there is a repeat of GAA. Normally, it is repeated 7 to 34 times. But in this condition, this fatty acid in Friedreich's ataxia, it is repeated 100 to 1700 times. Okay, and when that happens, body will not produce the protein. Okay, and this protein is called praxetin. Okay, it's a mitochondrial protein. Now, as you know, our nervous system and heart, they have a very high activity. They have very high activity in terms of energy usage. Okay, so if there is a deficiency, it begins in childhood. Okay, these children will have difficulty walking. They will have muscle weakness, loss of proprioception, and easily fatigued. Okay, remember there's less ATP, so they are easily fatigued. There is nervous system damage, so there's going to be difficulty walking, muscle weakness, and loss of proprioception. Okay, and it happens, this condition worsens from leg upwards. Can someone tell me the other disease which causes paralysis of the leg upwards? It starts from the leg, moves upwards. What's the other disease in which there's paralysis from the leg upwards? Come on, guys. I told you this in the beginning of the class also. What is the other disease? The one in which a patient will have a diarrhea or a throat infection, and around 2 weeks later, they become paralyzed from the leg upwards. What is this disease called? We did this for spinal cord. Still no? Guillain-Barré syndrome. That is paralysis, okay? Paralysis from the leg upwards. And these patients, okay, Guillain-Barré syndrome, it actually has a very good prognosis. After about a month of treatment, the patient is fine, fully fine. His limbs will be working again, no more paralysis. But this gradually will need wheelchairs. And these patients will have heart failure, vision problems, hearing problems. And they usually die of HOCM. Okay, usually die of this disease. And diagnosis is genetic testing. MRI of spinal cord, And what is the heart test which you can do to diagnose this patient? What is the heart examination? What is the heart examination? Huh?
Echo.
Yes, you see the heart. And the treatment, no treatment. Sorry, no treatment. Can only halt, slow this. Treat the symptoms. Sad life for these people because there's no treatment. You can only slow the spread and you can treat the symptoms. Okay. So guys, one last time, I'm going to quickly recap the cerebellar thing, the entire cerebellar thing. Cerebellum gets information from 3 sources. Okay. If this is the cerebellum, it gets information from 3 sources: vestibular system for balance. The other one is spinal cord proprioception. The final one is cerebrum. It is coordination. If there is damage to the cerebellar system, it leads to ataxia and vertigo. And you need to be able to diagnose ataxia. Is it vermal or paravermal? Vertigo, you need to diagnose it as central or peripheral. Sorry. Yeah, peripheral. Okay. And based on these symptoms, you need to treat the patient. Okay. I hope you guys understood today's lecture. If you have any questions, you can ask. And a person asked me to show the anatomy structures. Guys, I'm going to spend like 5 minutes to show all the anatomy structures that we did. Okay. Can someone tell me what is this structure? This thing that goes from top over the thalamus, goes below. What is the structure?
Phonics.
No, no, not the fornix. This is
Cingulate gyrus.
this is a nucleus. Okay, let me take a different one. Okay, so let me show you the fornix first. Here is the amygdala. I'm going to remove the lateral ventricles. Here's the amygdala. Here's the hippocampus. And from that, there's a tiny, this structure is called the fornix. Okay, it goes to the mammillary bodies. And from the mammillary bodies, it goes to the thalamus. And from the thalamus, it gives branches to cingulate gyrus. Okay. Next, we have the earlier structure. Where is that one? No, not you. Guys, this is very important when reading CT scans. So I was in this. This is, can someone tell me what the other structure that goes above the thalamus is? Begins with a C. It ends with the amygdala at the bottom.
Caudate.
Yes, it's the caudate nucleus. Okay. Remember that. Cerebellum anterior, posterior, and the flocculum. Okay. Basal ganglia, there's no structure here. Thalamus. Here's the thalamus. Here's the brainstem, midbrain. Here's the thalamus. This is the lateral ventricles. Here's the corpus callosum. Here's the cingulate gyrus. Look at this. Just remember this. The cingulate gyrus that travels, that gets the signals from the thalamus is above the corpus callosum. Just remember that. Okay. So, guys, do you have any questions? I actually have one question. Do you guys think I should do a case discussion at the beginning of the class for the previous chapter, or should I do case discussions at the end of the class for that chapter? Just send me a message. Send either one for a previous class and 2 for this class. Which one should I do? Okay, I got 1 response, 2 responses. Okay. So I hope you guys understand this. The only thing you need for stroke discussion for most questions is knowing the homunculus, what supplies where. And you need to know about upper motor neuron, lower motor neuron lesions. Okay. This question I need to check because I feel like there should be a CT scan and this should be hypertonia. I need to check this. I'll send the answer later. And I hope you guys can understand this. I have a few more minutes. I will quickly just remind you again. Internal capsule. So this is the internal capsule. You can see this is the lentiform nucleus, and right next to the ventricle, you have the caudate nucleus. And here is something called the insula. So if you guys get a CT scan, you should be able to identify these structures. Okay. So guys, we are done for the day. I hope you guys understood this. It's a lot of information and it is the most annoying chapter. Try to go through this. And remember the limbic system, the fornix, how the fornix goes and penetrates the hypothalamus and reaches the mammillary bodies, because that is what we use to divide the hypothalamus into different regions. Okay. Make sure you check the Pape's circuit before the next lecture, because the next lecture is a lecture where I'm going to teach you guys how homosexuality occurs. Okay. How homosexuality occurs. This is actually related to the hypothalamus, and I will teach it in the next class. Okay. So